In this video, we're going to cover the examples for the sampling distribution of the mean. Our first example here says that given a normal distribution with mu equal to 100, which remember that is our population mean, and a standard deviation, or sigma, equal to 10, if you select a sample size of n equal 25, what is the probability that our sample mean is less than 95? Well, to do that, we use our formula. Z is equal to, our z-score is equal to the sample mean minus our population mean divided by the standard deviation of our sample. So this is equal to the sample mean minus the population mean divided by our standard deviation of the population divided by, and that value divided by the square root of your sample size. So let's go ahead and plug those values in. This is 95 minus 100 over 10 over root 25. This is negative 5 over 10 divided by 5 is 2. So this is negative 2.5. And then what do we do with that value? Remember, this is our z-score. So we look at our table on page 739, 740 from our book, or just wherever you can find that table. And that corresponds to a value of 0.0062 or 0.62%. And what does this mean? This means that 0.62% is the probability that our sample mean is less than 95. Because we're more than 2.5, or we're at 2.5 standard deviations below our value of the population mean. So very low chance. All right, let's do a next example. Suppose there is a 65% chance of what sample mean occurring, right? So I said that wrong. I'm sorry. Let me rephrase that. Let's go back up here. So we have given a normal distribution of mean with a population mean of 100, standard deviation of 10. If we select a sample size of n equals 25, ignore this next part here. And then we want to ask ourselves, there is a 65% chance that the sample mean is above what value? Well, if we have a 65% chance that x, our sample mean, is above what value, well, this corresponds to some value of x bar that has a 35% chance the sample mean is below this. I shouldn't call this x bar. So corresponds to some value that has a 35% chance that the sample mean is below that particular value, right? Because that's the same as having a 65% chance that it is above that value. All right. Well, what is that? Well, we have to look back at what is that value? We have to look back at that table again, and we look for where a 35% chance occurs, or 0.35 shows up on that table. If we look for that, this corresponds to negative 0.385 as a z-score. Okay, so if negative 0.385 is our z-score, we have a formula that tells us what the sample mean will be in order to give us negative in order to give us a negative 0.385 as a z-score. And that's this formula. So we just plug in our values. The population mean is 100. Our z-score that is related to the value we're trying to find is negative 0.385. The standard deviation we were given was 10. Our sample size was 25, so the square root of 25 is 5. We plug all of this in, we get 100 minus 0.77, which is equal to 99.23. So this will be our sample mean. If we get that as a sample mean, the 99.23, that means that there is a 65% chance that our sample mean will be above that value. All right, and we want to do one more example before we end this video. So example 2 asks ourselves, well, what if we had the weight of an energy bar is approximately normally distributed with a mean of 42.55 grams with a standard deviation of 0.045 grams? Our first question asks, what is the probability that an individual energy bar weighs less than 42.515 grams? Well, this actually goes back to previous sections. And we just use our formula. Z is equal to the single value of 42.515 minus our population mean, all divided by the standard deviation, right? So again, this is x is equal to 42.515 minus our population mean, which we were given as 42.55, divided by the standard deviation of 0.045. And we plug all this in. This is negative 0.035 over 0.045, which is negative 7/9, which is negative 0.77 repeating, or approximately negative 0.78. So we have a z-score of negative 0.78. We go back to that table again, and this corresponds to a percentage, or a value of 0.2177, which is a percentage of 21.77. So that would be the probability that an individual energy bar weighs less than 42.515 grams. And again, that was our formula from previous sections. We have a related formula when we're talking about sample means, but now let's do a question with that. So part B says, if we choose a sample of 4 energy bars, so we don't have a single bar anymore, now we have a sample of 4 energy bars, and we want to know what is the probability that the sample mean, so the average weight of those 4 energy bars, is less than 42.515. We have a very similar formula. This is Z is equal to the sample mean minus our population mean divided by the sample standard deviation, which is exactly what we had in the previous example, in example 1. So we take our population standard deviation divided by the size of the sample, the square root of the size of the sample. And that's our denominator. So this is 42.515 minus 42.55, but now the standard deviation we're dividing by is 0.045 over the square root of 4, because 4 was our sample size. Well, this becomes, well, the numerator is the same as the previous part A, so negative 0.035. And now we have 0.045 divided by 2, so 0.0225. And this is equal to negative 1.55 repeating. And if you go back to the table, and if you looked at these value related to the z-score of negative 1.55, this corresponds to 0.0594. If you rounded to z-score of negative 1.56, this corresponds to 0.0606. So our value, our percentage, should be somewhere between 5.94% and 6.06%. And really, you can use either something in between there, like 6%, i.e. 0.0600, or you can use either of these values here. Just depending on whichever you choose, it's actually fine. The answer should be accepted either way. And that is it for this video.